In this module of why air source heat pump field assessments matter, we will touch on why we, as field agents, check that the system installed can meet the load based on submitted documentation, and why we check for refrigerant leaks. These checks correspond to check C5 and C8 on the New York State Clean Heat Quality Assurance and Quality Control Air Source Heat Pump Checklist. In this module, you will learn the importance of properly sizing the heat pump and the performance, safety, and environmental risks with refrigerant leaks. For C5, field agents confirm that the site conditions are consistent with the load sizing analysis by reviewing the ACCA Manual J. Accurate building load calculations and equipment sizing are key to proper system design. A properly sized and designed system will operate efficiently, maximize home comfort, lower utility bills, reduce callbacks, limit maintenance, and increase customer comfort and satisfaction. A proper, well-thought-out system design is essential for increasing consumer trust and public perception of heat pump technology. A few tips to ensure a more accurate system design are: 1. Use an ACCA-approved Manual J load sizing analysis software and follow the ACCA Manual J standard for building heating and cooling load sizing. Although the New York State Clean Heat Program does not require ACCA-approved Manual J software is used, it is highly recommended that contractors only use ACCA-approved software. Second, use accurate building takeoffs in the Manual J model, which includes square footage, ceiling heights, wall, ceiling, floor, and window areas, insulation levels and window quality, infiltration or leakiness estimates, representation of above grade or below grade surfaces, and no modeling of internal surfaces that don't have heat loss, like the floor between two heated stories. It is highly recommended that infiltration estimates are determined using a blower door. The third is use heating and cooling outdoor air design temperatures based on the nearest ACCA or ASHRAE weather station data. Although the New York State Clean Heat Program allows the design temperature to be within plus or minus 5 degrees Fahrenheit of the ACCA or ASHRAE design temperature, it is recommended that the ACCA or ASHRAE design temperatures are used exactly as is. And number 4, size a whole home heating system so that the maximum capacity at the design temperature is between 100% and 120% of the design heating load. For C8, field agents sample for refrigerant leaks at exposed field connections using a refrigerant leak detector. Refrigerant leaks can be expensive, hazardous, and harmful to the environment. Proper flare fitting, brazing, and charge testing are critical to efficient heat pump system operation and for the equipment to last its designed life. Connections are checked to ensure the optimum performance of the system, the safety of the occupant, and the protection of the environment. NYSERDA Clean Heat Connect developed this instructional video on proper flaring technique. Check it out to learn the proper steps to take and tools to use so you can prevent refrigerant leaks. Field agents keep refrigerant leak detectors maintained by cleaning sensor tips, storing the tool in a dry and clean space when not in use, and removing batteries when not in use per the manufacturer's instructions. Any installers that use refrigerant leak detectors must check manufacturer's requirements if equipment needs to be regularly calibrated. When it comes to performance, refrigerant leaks can lead to an undercharged system. The more substantial the leaks, the greater their impact on energy and operational performance. An undercharged system can lead to reduced efficiency, capacity, comfort, and longevity of the equipment. It can also lead to higher operating costs. When it comes to safety, refrigerant leaks can be very dangerous. Since refrigerants are heavier than air, refrigerant leaks in an enclosed area can displace room air and lead to oxygen deprivation for occupants. Breathing in high concentrations of refrigerant vapors can lead to unconsciousness and heart irregularities. It is critical that there are no refrigerant leaks inside the home. Refrigerant leaks are a problem. Contractors that take extra precautions to prevent leaks play a vital role in the fight against climate change. Hydrofluorocarbons, HFCs, like R410A, commonly found in residential heat pumps, have a global warming potential thousands of times greater than carbon dioxide. Some older residential heat pumps may still have HCFCs like R22, which has both a high global warming potential and ozone depleting potential. As a result, refrigerant leakage can lead to a substantial release of greenhouse gas emissions. Always follow appropriate procedures, pressure tests, and evacuate the lines before charging a new system with refrigerant to ensure no leaks. This concludes Module 2 of Why Air Source Heat Pump Field Assessments Matter.